Okay, just quick introduction to chapter 2. What are we going to learn in chapter 2? Chapter 2. Introduction. We're going to talk about statements and logic. And also truth tables. So when you're talking about any statement, we can sometimes verify that statement to be true, to be false. Sometimes we don't know. Sometimes the answer is not completely true or false. We're not working with those statements in math. In math, we have a statement. If for sure we can determine, is it true or it's absolutely false? A statement, mathematical statement, is a sentence which is true or false, but not both at the same time. So this is an official definition of a mathematical statement. We denote mathematical statements by P, Q, R, and so on. For example, you can say that, hey, this is my statement. 2 plus 2 is 5. You can easily verify that if it's true or if it's false. Another example. Equation x squared minus 1 equal to 0 has 2 solutions. It's easy for us to verify these statements. It's either true or false. We have no doubt about truth or falsity of these statements. As usual, we're interested in combining statements and create a new statement. Our goal is to create new statements. So since we are creating new statements, we need some operations. We introduce some operations to create new statements. Well, suppose you have a statement like P. Let P be a statement, mathematical statement. We're not talking about everyday sentence. We're specifically working with mathematical statements. The very first operation that we're going to introduce is negation. Negation is our first operation. It's denoted by tilde, tilde. P open a discrete structure book, you might see this symbol as well. Negation of. How do we read these? Not P. Not P. Not P. It doesn't matter if you use tilde notation or negation notation, both of them have the same meaning. So this is negation, our very first operation. We can use and or to create new statements. Let P and Q be two statements. We have the following. We have P and Q. This is the wedge operator. We read as P. We use a different color. P and Q. We read it as and. P and Q. It is true if and only if both P and Q are true. If and only if P and Q are true. Next operation, connecting two statements, P or Q. Upside down wedge. Or P or Q. Which is false if and only if both P and Q are false. If and only if. So instead of writing if and only if, I'm just writing it in short format, IFF, if and only if P and Q are false. We can connect two statements together using implication. P implies Q. If P, then Q. If P, comma, then Q. We're going to talk about the truth and falsity of this operation later. And finally, we have P, if and only if Q, biconditional. And this is conditional statement. If and only.